Hello, my name is Gideon, and this is a demo video of my URL shortener server application. Okay, so this is a scalable server-side application for shortening long URLs. Okay, so I started by taking the template provided by MLH, and then I built the actual URL shortening application. Okay, so I did that by implementing the CRAD endpoints for user management, URL operations, and then also event tracking. Okay. So after I built the actual application, I shifted my focus to the main goal of the hackathon, which is the production engineering request. Okay. So I focused mainly on the scalability quest because I was targeting the price for that one, which was on the Raspberry Pi 5 starter kit. Okay. So I started with the bronze tier, and the objectives were to simulate 50 concurrent users hitting the service, but you first have to install cases, so you have to document our response time, which is the latency and the error rate. Okay. So I did that, and these are the results. Okay. So this was the run I did on my local machine, and as you can see, I was getting 2.49 seconds, P95. Okay. So that's the latency, and then also yeah, and the error rate was 0%. Okay, so this was kind of fine because there was no target, there was no target to hit in terms of the latency or the response time. Okay, so yeah, so I took a screenshot of the terminal output showing 50 concurrent users, which is this one, and I also document the response time and sorry, yeah, the baseline P95, which is also this one. Okay, so this is the average, and this is the P95 actual P95 2.5 seconds. All right, so yeah, I move on to the silver tier. Okay, and the main objectives were to ramp up to 200 concurrent users, run two instances of the app, and also use Docker Compose, and also put a load balancer like Nginx in front of the to split traffic between the instances. Okay, and then the speed limit was to keep the response time under 30 seconds. Okay, so yeah, did that one too, and then this is Docker PS showing multiple instances running. Let me go to silver here. Right. So this is the silver. So this is the you have to provide a Docker PS to show the multiple instances running. Okay. So I'm having two servers, which are the instances, one in Nginx and the other services PostgreSQL in the database. Okay. And the next check was to show the load test results with a success with 200 users. Okay. So yeah, the initial run on my machine resulted in this results. Where is it? Where is it? Yeah, I initially got this result from the run on my machine. Okay, so the latency on the P95 was around 26.6 seconds. Okay, so eventually I realized that it was because of my low end machine. Okay, and I moved on to run the test on the virtual machine, which is data ocean droplet. Okay, and I got a latency to be under the 3 seconds, which is 2.57 seconds. Okay. Realizing that the results was due to my low end machine, I went back to the bronze test and I ran it, and I had better results, which was a latency of 0.85 seconds compared to the previous 2.49 seconds. Okay. So after completing this tier, the silver tier, I move on to the gold tier. Okay. So this part was quite interesting. Okay. So I didn't make any changes to my server. Okay. So I simply increased the concurrent users to 500, and my initial run resulted in this error. Okay. So the Nginx was giving an error that the 512 local connections were not enough. Okay. So I quickly fixed this by increasing the local connections to 4096. So I multiplied it by 8 times, okay, to handle the 500 concurrent users. And then the rerun resulted in 0% error rate. Okay, so the initial run for the 500 concurrent users resulted in 92% error rate. Okay, which was very bad. And after the fixing, after increasing the Nginx request, I got 0% error rate, as you can see from the results. And then the response time was 6.2 seconds. Okay. So there wasn't any speed limit for the go tier, but I was aiming for like something better. Okay, so I did that by increasing the request. I first increased from 2 to 4, and I didn't get any significant results. And then I increased from 4 to 8, down to I didn't get any significant results difference. It was still around 6.2 seconds latency. Okay, and then I duplicated, I doubled my um, servers. Okay, so now instead of two instances of the servers, I had four instances. Okay, and then I got better results, which was now 5.6 seconds. Okay. Right. So the verification for the tier 3 were evidence of caching. So which is this screenshot right here. Um, this one. Okay. So as you can see, the first request hits the the endpoint. Okay, and then it was a miss. Okay, so no caching for that one. So the request went straight to the database. Okay, and then the second request was a hit. Okay, because this time around the previous response has been cached in the Redis, and now the request went straight to the Redis instead of the actual database, which is much slower, and the Redis is much faster. Okay. So that one resulted in a hit. The next requirement was the load test results with less than 5% of errors. Okay, so that one would be the final run, which resulted in 0% error rate way below the less than 5%, and also pretty good latency or response time, which is 5.62 seconds. And then the bottleneck report. So this is my bottleneck report. So the first tsunami, yeah, I can see it here. So thank you for watching this demo video, and I'll add a link to the repo in the description for you to check it out. Bye.